Now, let's engage in some practical exercises on elastic network interfaces. To get started, we'll launch two EC2 instances. I'll scroll to locate the Amazon Linux 2MI, specifically the T2.micro type. Next, I'll select the appropriate key pair for secure access. For network configuration, I'll opt for an existing security group, specifically my Launch Wizard one. This setup looks promising. After confirming these choices, I will proceed to launch the two instances by clicking on the Launch Instances button. The objective here is to study the network interfaces associated with these instances. Once they are running, we'll explore their details. If we examine the networking section for each instance, we'll discover each has a unique network interface assigned to it, commonly referred to as an ENI, which stands for Elastic Network Interface. Each network interface is identified by its unique ENI ID and comes equipped with several features, including a public IPv4 address, a private IPv4 address, and a private IPv4 DNS. If we turn our attention to the left panel of the AWS Management Console, we'll see that each of our two instances has its distinct network interface. Navigating to the Network and Security section, we can locate the Network Interfaces section. Here we will find both of the ENIs created, with each being attached to their respective EC2 instances. To confirm their attachment, we can check the status, which should indicate in use, and we'll also see the corresponding instance IDs. One useful feature we have at our disposal is the ability to create a new network interface. For this demonstration, we can add a description. Let's call it Demo ENI. Next, we will select a subnet for our ENI, ensuring it's assigned to a specific availability zone, AZ.
Let's verify first where our instances are. Magnificent, here they are. In EU West 1A. Let's select this availability zone. Okay, so now we select it in the menu proposed.
We can also choose to automatically assign a private IPv4 address or specify a custom one within the selected subnet. For simplicity, we'll go ahead with the auto-assign option. Additionally, we can associate a security group with our newly created network interface. Now, let's create this network interface. Once completed, we'll see our newly created Demo ENI listed here. Essentially, through this process, we've effectively created a secondary private IPv4 address that can be utilized by our instances. What we're going to do now is connect this to our instance. We can accomplish this by going through the options and selecting the action to attach, followed by choosing the specific instance we wish to link it to. I'll go ahead and select this particular instance and proceed to attach it. Once we've completed the attachment, we can go to our instance and refresh the page. Let's navigate to the networking section and scroll down a bit. You'll notice that this instance is equipped with two network interfaces. One of these is designated as the primary network interface, which provides both a public IPv4 address and a private IPv4 address. In addition, we have this Demo Elastic Network Interface, ENI, which provides an additional private IPv4 address. Now, you might wonder, why would we go through this process? The answer lies in the flexibility that an ENI offers. We have complete control over this ENI. For instance, we could easily transition it from one EC2 instance to another. Imagine if both instances are running the same application and you want to ensure they can communicate using their private IPv4 addresses. We can achieve this by transferring the ENI. The primary advantage of this approach is that it allows for rapid and seamless network failover between the two instances. By shifting an ENI, we can effectively move an IPv4 address from one instance to another without significant downtime. Let's now demonstrate this process. I will select the ENI we just mentioned and proceed to detach it. Confirming the action, I'll click on Detach. It will take just a few seconds to complete the detachment, after which we can reattach it to the alternate instance. Next, we can choose the Attach action, allowing us to select another instance to connect to. Let's confirm that's the instance we want. I'll proceed with attaching it to the selected instance, and the process is now underway. If I refresh the page again, you'll notice that from the two existing network interfaces, only one remains on this instance. Meanwhile, the other instance now hosts two network interfaces. This demo Elastic Network Interface, or ENI, has successfully transitioned to the other instance. This functionality showcases how we can implement failover between instances using ENIs, which is a quite powerful feature, though a bit advanced. It's advisable to experiment with this on your own for better understanding. Now, let's go ahead and terminate these instances to see the outcome. As they begin to shut down, let's take a moment to consider what will happen with the ENIs. Currently, we have 3 ENIs in total. 2 were automatically created alongside the EC2 instances, and 1 was created by us manually. So, what do you think will occur? If you guessed correctly, then you'd be right. The ENI that we manually created will persist, while the 2 that were automatically generated with the instances will be deleted automatically. By creating your own ENIs, you gain enhanced control over your private IPv4 addresses and your overall networking configuration. This can be particularly useful in various advanced scenarios. As we monitor, we can see one ENI has already been removed, while the other should disappear shortly, and that sums up this hands-on demonstration. You're welcome to retain the ENI if you wish, or you can delete it, as it won't incur any costs. Thanks for joining this session. I hope you found it valuable, and I look forward to seeing you in the next lecture.